Hi, this is Rafael, and this is my project for Capstone 1 on DataTalent Program. It was a climate change data analysis, so I've used Python with pandas, NumPy, and Bokeh, and the analysis relating CO2 emissions to temperature anomalies and sea level rises. Um, we'll review some consequences of this relationships. Um, what I used mostly with pandas and NumPy is to cleaning and merging and doing calculation on the data, and Bokeh to the interactive and comparative visualizations. All three indications are pretty strong. I got a 93% direct relation, which is really, really strong in terms of mathematics and statistics. Uh, The sea level rise reflects both thermal expansion and the oceans of the oceans and the melting of ice. That means it's not just rising because the ice is melting. It's rising because, as we know from Physics 101, when you heat something, it expands, and the amount of energy to rise the temperature of the whole all the oceans at the same time, it's really huge. That's why the expansion is very visible, let's say. Um, yeah, you'll see the correlation in the graphs. The first one is temperature and CO2 emissions. The red line is the correlation. And the second graph is for the temperature anomalies and the sea level. So it's really straightforward, the relationship between them. This is part of the code for the correlation. It's the first plot, so I did uh, both of them separately. Some calculation for the trend line on each one. And the last part is just a grid plot to aggregate both graphs together in the last image you saw. I have a second graph. This is a normalized trend. So uh, since it's hard to measure then at the same time, I mean, for sea temperature levels, it rises like 1 degree Celsius. So if you put together with the CO2 emissions, which in the has tons of billions of tons of CO2 in the atmosphere every year, it's you see just a flat line of the temperature, right? So this is how we compare the graphs in a normalized form. So they all go from a scale from 0 to 1, and you see the trends there and how they behave. And this is part of the code, the normalization calculation on top, and then all three lines. And for the interactive graph, there's a hover option there. And lastly, I did the three graphs separately. So you see the temperature rose just a little bit over 1 degree over the past 30 years or so. But it's enough to have some huge effects. This is CO2 emissions. It's so that's 24,000 to 38,000. It's actually in the house of billions of tons of CO2. So 24 billion to 38 billion tons of CO2 emissions. You see a little drop there in 2020. We all know why. And if you can relate here, you see on 2020, the temperature got lower a little bit, right? But when you go here to the sea levels. It didn't happen to affect the sea level because it was just a short time. So we know that to lower the sea levels, we need to get the temperature lower for a longer period of time. So the pandemics wasn't enough to affect that. But you all see the trends. They all three factors rise together, and they're all rising. Okay, so this is the last calculation. So the three graphs separately, and so why did I do all that? What are the consequences and impacts? So sea level rising, where I already spoke about the glaciers melting and the warm temperatures expanding on the oceans. That has another consequence, which the ocean absorbing the CO2 from the atmosphere, which changes the sea level's pH. So the pH lowers and the water gets more acidic, which is pretty bad for all life in the ocean. They are very sensitive, most of them. Um, we also have the problem with low levels of oxygen. So the hotter the water, the less oxygen it will hold, which threatens marine life. And the stratification is the layering of the ocean. So it affects the exchange between the hot part of the sea, which is the top one, and the bottom part of the deep seas, which is very cold. So that's the effects on the oceans themselves. Now the impacts for marine life and the ecosystem. So heat waves are pretty bad overall in general for everything that lives in the ocean. Coral bleaching means corals will expel the algae that is attached to them, and due to stress and the temperature rises, and that's pretty bad because that's part of an ecosystem responsible for 25% of the marine life. That also affects the harmful alga blooms that we see sometimes, red tide and other effects. The temperature can also affect migration patterns and the routes and breeding times for marine species. And we have the example there for penguins, and we know other species are always heavily affected by this kind of changes in the oceans. And lastly, we see the impact for human communities. We see fisheries and people who depend on fishing for living are already being affected. We have coastal impacts for erosion and loss of land in low-lying coastal areas, and disruption of coastal economies, of course, because not just fishing, but also tourism and other activities are being affected by that. So for conclusion, the graph shows how those factors are intertwined. Focusing on reducing emissions will help greatly on the effects of climate change and all bad things that's happening to the oceans. And open and clean data will help governments and other institutions to know the problem and to focus on the solutions and support sustainability efforts throughout the globe. And lastly, or references. So I got data from a few different places. Had a compilation of I did research on other sources, but the compilation of all the effects on the oceans can be found on Wikipedia. And I'll be also sharing my GitHub link for the project itself with the collab file and all the CSV files. Thank you.